I'm Rakesh. I'm from Bill Institute of Technology and Science, Pilani. We have been submitting a project for the NIT Bhopal contest, Zigbee contest in Srajan. This is our paper 83, Non-Invasive Health Monitoring System of a Zigbee network for hospitals. So, myself is Rakesh Krishna. This is the prototype which we have made until now. So as you can look in this prototype, this is a development board over which MSP 430 is mounted. This is the microcontroller which we are using for the project, and this is the Zigbee transmitter module. This is the PPG sensor. PPG sensor comes to place in the non-invasive health monitoring system, as it can detect the blood pulse rate and hemoglobin content without actually pricking the blood. And this is the GSM module. Apart from that, we have Zigbee receiver module on this side. This Zigbee receiver module is connected to the laptop here.
Myself Srajan, I will be discussing on communication part involved in our project. Here we are receiving pulses. So actually we start with this. This is basically the detector where we put the finger and the pulses are detected by the photodiode. Now when pulses are detected by the photodiode and sent to the PPG sensor present here. PPG full form is photoplethysmogram sensor. So current from the photodiode here is sufficient to drive the PPG sensor present here. Basically, you can see the LED present on the PPG sensor, which is sufficiently driven by the photodiode current present in the knob. So data received here in the PPG sensor is sent to the MSP 430 microcontroller, which is provided by Texas Instruments. From MSP 430, that data travels to this Zigbee module, which is from Milan system, and module name is Tarang. This module operates at a frequency of 850 to 1800 MHz, giving it a range of approximately 30 meters. From Zigbee transmitter modules, we move on to the Zigbee receiver module. So basically, data is transferred wirelessly from the transmitter end to the receiver end present here. Now, this completes the part of our wireless communication. Now, we have to obtain the data on the hyper terminal on the laptop, which is accomplished using a RS-232 cable. So basically, RS-232 cable is connected to the laptop using RS-232 to USB converter, which is a CH430 cable. Now, regarding RS-232, its high level voltage is around 12 volts, while the low level voltage is around minus 12 volts. It follows serial communication, that is, data is sent bit by bit. It is based on NRZ scheme, which is again non-return to 0. Now I'll explain something regarding MAX232 IC. It is present on the receiver side. We can see it. This IC is the MAX232 IC, where the LED is blinking. Now for MAX232 IC, it is an IC used in serial communications. For level conversion, depending on requirements of voltage levels, it converts serial data. Now something on RS-232 protocol or serial protocol. It is a serial protocol used for communication between two devices. Like here we are communicating between our laptop and the data present on this receiver module. Now for longer range of communication, DCP, that is data communication protocol, and RS-485 are used. Here we are using the protocol to establish an interface with the computer's hyperterminal.
Now I will explain the block diagram. Here, as you can find, as I explained you the whole circuit. Now let me show you the block diagram here. Here in this block diagram, you can find this is the algorithm. This is the algorithm. Here the power supply is taken. The power supply is from 230 volts, so we'll step down to 12 volts using a step down transformer. And this power supply will be, the main power source for the entire circuit First of all, when you start the prototype, the first thing which will switch on is the LCD indicating our name of the project, and later on Zigbee and GSM modules are activated. So if you look on both these sides, these are about the sensings. This is LM35, which is a temperature sensor. It ranges -55 to 150 degrees Celsius. And this is the PPG sensor, the photoplethysmogram sensor. It is based on LM358N comparator IC. So, looking at the temperature sensing, the data which is analog in nature is from the LM35 sensor is transferred to the microcontroller. So, in the middle we have ADC conversion, but MSP430 has an inbuilt ADC. Here, in general, the data, the temperature value will be known in Fahrenheit, so we'll use the formula F equal to 9/5 into C plus 32 here. So after that, this temperature is compared with a set temperature value. Let us say a normal human has 98 degrees Fahrenheit, so this temperature is compared, and if it is yes, a SMS will be sent through the GSM module, or else the data will be updated on the doctor's laptop using RS-232 protocol. Something similar occurs here. Here the PPG also gives the information about the pulse rate, and it is compared with the set value of 72, which is the normal heartbeat value for a healthy person, and again the same thing occurs either through a GSM or through the hyperterminal. Now this is the reception part from the external environment, where here this is the daughter board, the MSP430 board. As you see, the green color board in our project. This MSP430 is a low power CMOS design of 3.3 volts. Here we are using GSM and Zigbee. So to switch between GSM and Zigbee, we use a SPDT, single pole double throw relay. This relay operates at 12 volts. This relay switches either to Zigbee or to GSM, depending upon the kind of application you need. So since this is 3.3 volts and this is 12 volts, and the Zigbee again operates at 5 volts, there are a lot of voltage mismatches. So that is the reason, as pre-discussed, we use MAX232 IC. So coming to here, this is the Zigbee module which operates at a range of 850 to 1800 megahertz, and we use a GSM module, SIM-RF, which will communicate with the doctor's mobile. So on the receiver side, so this data from Zigbee transmitter will be sent to the receiver. So on the Zigbee receiver, as explained previously, there is a MAX232 IC which is used for level conversion, and it sends the data to the DB9 port. Generally, the computers have DB9 ports. For the laptop, we are using RS-232 USB converter. So this is our laptop. So inside the laptop, we have a hyperterminal where the data can be updated. So let's look at the working of our project. Well, now the circuit started working. So let's, the T stands for temperature and B stands for the blood rate. So the room temperature is around 59 degrees Fahrenheit. So on the computer, using RS-232 cable, we are opening a communication port which is updating the value of temperature of 59 degrees currently. Now I place my hand closer to this. Owing to the temperature in Pilani, it would be a lower value. So this is how the temperature getting updated. Now, to indicate a rising temperature, we use a matchstick, which can be brought closer to the temperature sensor, LM35 temperature sensor, and this data will be updated. You can look at the value which is 62 degrees Celsius and 77 degrees Celsius, sorry, Fahrenheit, which are quite higher. This LM35, as I said, has a range of minus 50 to plus 150 degrees Celsius. It can detect the temperature within that range. Of course, Fahrenheit will also lie somewhere in lesser values. So this is how the data from the transmitter is sent to the receiver wirelessly without any connection. But the connection is with the is from the receiver to the laptop's hyperterminal. So this is where the wired communication comes. Even you place this board at 30 meters distance, the Zigbee can send the data. So here the MSP430, the main function of MSP430 is for comparison of the values of 59, 64 with the standard set value, and also these sensors will get the value. And this is the relay. This yellow color thing is the SPDT relay, which works at 12 volts. This relay switches either between the GSM or Zigbee. So let us say the temperature recorded is 1 or 2 degrees Fahrenheit and it is higher than 100 Fahrenheit, which is the set value. So at this stage, what happens is the relay switches to the GSM and not to the Zigbee. So in that case, the doctor will get an SMS. So till now we have completed till the Zigbee and PPG part. We are yet to do with the GSM part. Thanking you.